Okay, so in this video, we're going to discuss how to solve equations using the square root property. And just a short refresher on what a square root is. A square root is a number that produces a specified quantity when multiplied by itself. And basically, when you're given a square root, say the square root of 49, what it's really asking is, what number can you multiply by itself to give you 49? So, if you remember your multiplication tables, you'll remember that 7 times 7 is 49, so the square root of 49 is equal to 7. So, this first equation that they're giving us is saying solve 5x squared plus 1 equals 51. And you have to do that by using the square root property. Well, you're not going to take the square root of both sides right off the bat. What you need to do, just like any other algebra problem with an unknown, is isolate your unknowns, in this case your x squared, on one side of the equation, on one side of the equal sign, and your knowns, your constants, on the other side of the equal sign. So you can solve for your unknown by setting it equal to the known quantity. So the first thing we're going to do is subtract this 1 from both sides of the equation, and that'll give us a 5x squared equals 50. And we're not changing the value of the equation because we're doing the same thing to both sides. We're subtracting 1 from here and subtracting 1 from here, so that gives us 5x squared equals 50. Now we still want to isolate this x squared term, so we divide both sides of this equation by 5. And that will give us x squared equals 10. 5x squared divided by 5 is x squared. 50 divided by 5 is 10. So now we can use our square root property, our square root, to find what the value of x is. If x times x is 10, then 1x is going to be equal to the square root. And we can take the square root of both sides here. Square root of x squared equals square root of 10. Now the square root of x squared is x. Any number times itself, the square root of x squared will give you x. Now the square root of 10 is, we have to consider the possibility of when that's a positive or when it's a negative. So we'll have to look at the square root. It'll be the positive or a negative square root of 10, because a positive square root of 10 times a positive square root of 10 will give us 10, and a negative square root of 10 times a negative square root of 10 will also give us 10. Now we can plug these back in to our original equation to make sure we don't have a solution that it makes our equation not true. So we'll have 5 times the square root of 10 squared plus 1 equals 51. Well, square root of 10 squared is 10. So, and then 5 times 10 is 50. 50 plus 1 is 51, so that checks out. Now, 5 times a negative square root of 10 squared plus 1, does that equal 51? Well, a negative square root of 10 times a negative square root of 10 gives us a positive 10. Negative times a negative is a positive. Square root of 10 times the square root of 10 is 10. So 5 times a negative square root of 10 times a negative square root of 10 gives us 50. 50 plus 1 equals 51, so that checks out. So our solutions for this problem are when x equals a positive square root of 10 and a negative square root of 10. Has to be both of them because both of them are possible solutions. Now our second equation we're being asked is to solve x minus 3 squared equals a negative 64. All right. Well, we've been told to use the square root property. So we've got our unknown equation over here, our unknown part of the equation over here, and our known over here. So if we take the square root of both sides, we can say the square root of x minus 3 squared equals the square root of a negative 64. So the square root of x minus 3 squared will give us x minus 3. And then the square root of a negative 64 is, well, the square root, it'll be the same thing as the square root of 64 times the square root of negative 1. And the square root of 64 is 8. Remember from your multiplication tables, 8 times 8 is 64. The square root of negative 1 is an imaginary number that we show as I. So x minus 3 equals 8i. So x, let me back up here. We also have to consider, just like in the last one, we have to consider when it's a positive or a negative. So when we take the square root, we have to consider both when it's a positive or a negative. So the square root of a negative 64 is a positive or a negative 8i. So our solution is x equals, if we add 3 to both sides of the equation here, x equals 3 plus or minus 8i. Now we can go back and check this here, just like we did with our first equation. So we'll plug in our value for x here. 3 plus 8i minus 3 squared equals negative 64. All right, well 3 minus 3 is 0, and 8i squared gives us 64. I times I will be a negative 1, so that gives us a negative 64. That checks out. If it's 3 minus 8i minus 3 squared equals a negative 64, well, 3 minus 3 is still 0, so you've got negative 8i squared equals a negative 64. So negative 8i times a negative 8i gives us a positive 64i squared, but I squared, remember, is a negative 1, so that does give us a negative 64. So that checks out too. So our solutions for this equation are also, there's two solutions. It's x equals 3 plus 8i or x equals 3 minus 8i. So when we're solving by using the square root property and we're taking the square root of both sides, we have to consider when this is positive or negative. So using the square root property will give us two possible solutions, and then we'll have to check and make sure that those possible solutions satisfy our original equation.